So let's chop up a few top-level ideas regarding generative AI. First, the concept of performance compression. There's going to be performance compression in many fields, which means that the bottom quartile or bottom half of performers are going to use AI to become slightly above average. So here's just a picture of what that looks like. Here's the bell curve for many human skill sets. And if you have AI operating here sort of in the middle, then someone who's operating way below the middle is going to just use the generative AI to catch up to the middle. So what does that mean? So let's take a simple example of this in writing. So let's say we rate all human beings on a scale of 1 to 100 when it comes to writing, where 30 or below is illiterate. So it's a person who cannot write a 5-paragraph essay. Now, generative AI today can write a 5-paragraph essay. So everyone who is 30 or below now moves up to say that the 30 to 40 range, wherever the AI is performing. So that means that all the people who are 30, 40, 50, right around that level, the AI is operating at, are now going to have a lot more competition, which means that their income is going to go down. So I call that performance compression, the mediocre catch up to the good. Second is the concept of wealth dispersion. What will happen to wealth as a result of AI? So there's this little known fact that in the original software development research that was done on high performing teams by people like Copley, that there were actually 2 models of high performance, not just one. So one line of research showed that highly collaborative teams were high performing. These are now known as agile teams, so everyone knows about these. What people don't know about is what I call the wizard model. So research also shows that wizard model is high performing. And so in the wizard model, there's a wizard with a lot of helpers. So the wizard has the entire system in their head, and they just ask the helpers for assistance to do things that are much simpler, like set up a database. What AI does is that it allows anyone to become a wizard because the assistants are now replaced by an AI. So consider a product engineering person who is creating a SaaS. Previously, they would have to think about how to do social media, how to do customer support, and how to do all sorts of other things that they're not experts in. And that is not really their focus. So their focus is on product development. So that would cost them. Either they would have to do the work themselves, or they would have to hire someone to do it. Now an AI assistant can do the social media. Now an AI assistant can do the customer support. Now the AI assistant can do the legal work. So people who take advantage of this technology quickly are going to zoom up the revenue scale. And we're going to see people making 10 million, 100 million, even $1 billion overnight. And I would not be surprised if there are many DTC companies that see their revenues 5x or 10x in 6 months as a result of AI. So this is what wealth dispersion will look like. So which is that the very, very best will get richer than Oedipus, right? So there are going to be single person $1 billion companies. Next is that generative AI is not very smart, but it doesn't really matter because humans aren't very smart either. We're just extremely arrogant about how smart we are. So the data from Kahneman and a bunch of other places show that human beings are in autopilot mode approximately 80% of the time. So if you take all of these things that we're doing on autopilot and replace them with an AI, then an AI can do most of what a human does most of the time. So let's consider a typical project manager. They maintain the state of the system. They know the dates, they know who is doing what. Now an AI can do much of that, right? The AI can read the requirements and answer questions about them. It can read the Gantt chart, it can listen in on all of the conversations and answer questions about them. And so whenever anyone has a question about the state of the system, now the AI can answer it. And it does this all of the time without resting. It can have 25 conversations with 25 different people at the same time. So automatically it does all sorts of things that a human can't do just because it's a computer. So let's quantify this intelligence thing with Bloom's taxonomy, which is these 6 levels here. So the first level of Bloom's taxonomy is knowledge or remembering. So I say that Paris is the capital of France, and then I ask, what is the capital of France? And the response is Paris. So that's knowledge or remembering. The second level is comprehension or understanding. And the typical test of comprehension or understanding is to distill or summarize or paraphrase something. And so that is a good description of what ChatGPT-3 does today. It reads the entire internet and then it distills it or summarizes it back in the form of an answer to a question. So it's remixing the internet. And so that's primarily where GPT-3 operates at today, at the knowledge and comprehension levels. And it doesn't really touch application analysis, synthesis, and evaluation. Unless, of course, it's simply repeating back an analysis or a synthesis that someone else has done. In which case, it's not actually doing anything. It's just going back to the comprehension and remembering stages. Now, the question is, will this behavior emerge as the language models get bigger? And so here's an interesting anecdote that will help you think about the edge of GPT-3's intelligence, and that's reasoning by analogy. So here's an example. I tell GPT-3 to take a look at this list. Give me 5 examples like it. So Boston, Massachusetts, New York, Sacramento, California. So the pattern here, of course, is state, capital, and state. That's what most humans would say. Now, it gives me just a bunch of cities and states. So it understands something, right? So it says, I'm going to give you city-state pairs. And then I tell it, no, actually, it's not city-state, it's capital state. And then it says, oh, okay, I apologize for the correct response, and here are the answers. So it gets some of it, right? It gets that one of them is a city and the other one is the state that it's in. It doesn't get the capital, which, you can actually argue that the pattern that it's found is also a pattern, although it's not the pattern that I would describe as the best pattern that most human beings would describe as the best pattern. So this is the edge of GPT-3's understanding. And so the question is, as we build bigger and bigger LLMs, will these higher levels in Bloom's taxonomy, like analysis, application, synthesis, evaluation, come for free, or do we need to improve the algorithm? So that is the fundamental question that is being asked, right? Do we have the right algorithm and we just need to create bigger and bigger models and feed more data into them, or do we need a better algorithm? And the answer will almost certainly be a bit of both. And the big question is it mostly one, we have already figured it out and we just need to throw more compute at it, or do we need a lot of help in getting a lot smarter? Now, GPT-4 is being created right now. It's supposed to be released in the spring, so that's Q2 2023. It's about 1,000 times bigger in terms of parameters, which is not really important, right? That's an input, not an outcome. So the question is whether or not that difference in size is going to matter in qualitative performance. And no one knows the answer to that question except the people who are developing it. And so the final thing I'll do here is to make some simple predictions. I think both of these predictions are quite straightforward and they have at least a 90% chance of happening. The first prediction is that within 5 to 10 years, just about everyone, lawyers, doctors, engineers, are going to be working with an AI assistant. Of those 3 categories, I think that the people who are in the biggest trouble are software engineers. Primarily because software engineers are so incredibly arrogant about what they are doing. We still have a ridiculous number of extremely well-paid people just building very simple business apps with a simple front end that consists of a bunch of text boxes and a database backend. And no one should be making $200K a year for building simple applications like that. And AI plus no code is probably going to put an end to that. And that's going to make a lot of software engineers very unhappy. A second high probability prediction is that these tools, these AIs, will be used for political reasons. And in particular, they'll be used to win political races. So imagine an AI that has read everything that you have ever written online, plus has 100 data points on you from a data bureau. So it knows your income, your education, your address, your family. So it's now engaging with you across all the social media platforms, plus email, etc. So it's becoming your friend and it's trying to persuade you to do something such as buy a particular product or vote for a particular candidate. So that technology will exist by the end of this year. So in 2024, which is a critical election year in the United States, hundreds of millions of people will be subject to AI friends trying to persuade them to vote for a particular political candidate. And as a result, I think it's an easy prediction that 2024 is going to make 2017 and 2020 look like a walk in the park. So I'm happy to chat about this stuff. Feel free to reach out to me at this email or set up a meeting with me on my Calendly.